All right, here's 413 day 2. How can we describe any figure? We're going to use variables to generalize again. And in this one, we're going to pick up a problem 426 and kind of finish out. Please get this file online and try to go through it yourself first, because practicing it ahead of time will be better than just watching the video alone. All right, so Bonnie's the owner of the I've Been Found picture framing shop. She's excited about the work that you've done describing square frames in the previous problems and now wants to use your help. Use the algebraic expressions to help Bonnie with each of the following orders. Be prepared to explain how you found that. A customer wants a frame that's 8 tiles along each side. How many tiles will Bonnie need for the whole frame? So 8 tiles on each side. So we should probably use one of these that we came up with before. I'm going to go all the way back to 412, and we'll use Tina's method again. Is that okay? Yeah, let's use Tina's method that we had, the 10 plus 10 plus 8 plus 8. But when we were in the last class, we found that to be what was Tina's shortened method. X plus x minus 2 plus x minus 2. Okay, so let's go back here now to day 2. So just as a reminder for Tina's method, right, that was x plus x minus 2 plus x minus 2. The customer wants it 8 tiles long, so we can plug in, right, that what that tells me is x is the side length, and that's what our x represented, so we can say that x equals 8. All right, so 8 plus 8, if I'm using that up above, and then 8 minus 2 plus 8 minus 2. 8 plus 8 is 16, plus 8 minus 2, which is 6, plus 8 minus 2, which is 6. 16 plus 6 is 22, plus 6, which is 28. 28 tiles. Bonnie's neighbor wants a frame that's 6 tiles along each side. How many tiles will she need? All right, so 16 on each side. So we can do the same thing. 16 plus 16 plus 16 minus 2 plus 16 minus 2, right? And so I will figure out what's inside those right there. 14 each. I see some grouping opportunities here. 16 and 14 is 30. And that 16 and that 14 is also 30. Whoops. 30, right? So that's going to be a total of 60 tiles. 60 tiles. All right. A new customer comes into Bonnie's shop and says he wants a frame that's 25 tiles on each side. He used the expression 4, parentheses, x minus 1, to calculate that he needs 99 tiles. Bonnie explains that he actually only needs 96 total tiles. What mistake did this customer make? Well, we need 25 tiles, and we're going to use this expression. So let's say 4. Remember, we don't see it, but it means we got that in there. 25 minus 1. So what mistake did the customer make? So when we do this, what do we get? We should have 4 times 25 minus 1, which is 24. And 24 times 4, you can do the math on your own, turns out to be 96. So just like we expect. So what in the world did he do that he got 99? Well, it looks like he may have done what? He may have forgotten to subtract before multiplying. Looks like he did 4 times 25 minus 1. And that's 100. And that equals 99, right? That's not right. He did not use the parentheses first. Need to find what was inside the parentheses first, right? Define what's inside of there first, then he could do that. All right, Bonnie's father had 32 tiles that he wants to use to frame an old photograph. He needs to know the dimensions of the frame so that he can have the photo printed on at the correct size. What should Bonnie tell him? Ooh, 32 tiles. So I don't have 32 on the side length. I have 32 total tiles, right? I have 32 total tiles. Ooh. So we could do kind of maybe, I don't know, we could probably do some guessing, can't we? We could do, let's use this method down here. So it's 4x minus 1. And we need it to equal 32 tiles, right? So we need it to equal 32 tiles. So let's try this. Let's just try 5. Let's put x, let's do an x equals 5 here. Let's see what we get. Okay, so we have 4, 5 minus 1. 4 times 5 minus 1 is 4, that's 16. We use 32. Well, it's double. Maybe we should just double it, right? Okay, so we didn't hit that, but it's 32. 32 is double 16. So let's try x equals 10. Why am I doing that? There we go. 4, 10 minus 1. 4 times 10 minus 1 is 9. That's 36. Ooh, that's too big. So we can't just say that if we double the sides that we double this, right? That's not how that works. Okay. All right, so let's try another method though, or let's try another number. We noticed that 5 is too small and 10 is too big. So let's try 8. X equals 8. So 4, 8 minus 1, 4 times 7. 4 times 7 is 28. All right, too small. Let's try 9. 4 parentheses 9 minus 1. 4 times 8. 4 times, there it is. 4 times 8, 32. There we go. We got it. So what can we tell Bonnie's dad? We can tell him the correct size is 9, right? 9 on each side. Okay. Bonnie has a set of 40 tiles that she bought while she was traveling to South Africa. Ooh, what's the largest frame size on each side that she can make with these tiles? Will she use all of her tiles? Well, we already know that if we did a 10, right? If we did 10, we get 36. So let's try 11. X equals 11. All right, so we use our previous knowledge there. So we have 4 times parentheses 11 minus 1. 4 times 10. 4 times 10 is 40. Hey, that works, won't it? Will she use all of her tiles? Yes, she will. We can use them if we have a side length of 11. There we go. If you're following along here, you'll see that, if you do 8, 9, and 10 right here, and 11 you can see down the lower left, notice that they're increasing in this case by 4s. 28, 32, 36, 40. So if for some reason there were 42 tiles, we couldn't use all the tiles, could we? We could use 40 of them, but we would still have 2 of them left over, right? All right. Bonnie has recently remodeled the Iben Frame picture framing shop and can now make larger frames. She has just received an order for a square frame that is 102 tiles along each side. Yow. How many tiles will she need to make this frame? Explain how you got your answer. Well, let's use what we had up above, right? Let's do this. We have 4, right, parentheses. We would have to do what? 102 minus what? 1? Yeah, minus 1. Almost forgot how to do that. So then, right, so that means, right, that our x equals 102 tiles on each side. I wanted to emphasize that, I suppose. 4 times 102 minus 1, which is 101. 4 times 101 is 404 tiles. Wow, that's a lot. Bonnie's been hired to make a frame go around a large mural. A mural is a very large painting, usually put on a wall. She has 300 tiles to use. How many tiles should she place along one side of the square frame for the mural? Work with your team and be prepared to describe your process to the rest of the class. Okay, now there is a method to this, right? There is a method. And maybe you're starting to see the method. I'm not sure. However, if you're not seeing that method yet, that's okay. That's all right. Just keep kind of plugging along and seeing what you can do, okay? So we need 300 tiles. We know that 102 is too big, right? We know 102 is too big here. So we could just try, we could try 50, right? We could say it's 50 on the side. And let's see what we get with that one. All right, so 4 times 50 minus 1. 4 times 50 minus 1 is 49. Ugh, 4 times 49. That's not a nice number, is it? 49. And 6, 3, 196. Well, that's not very helpful. That's way off, isn't it? So we need something bigger than that. So as we're guessing, as we guess what we're doing, we can, there are tricks to our trade there, if you will, to doing that. Somehow we always have to do a kind of a division by 4. So what I'm going to do is I'm going to take that 300 and divide that by 4. 300 divided by 4, 7, 20, 75. Okay, so does that mean I need 75 tiles? That could be. It might not. Let's find out. Let's say that x equals 75. All right, so 475 minus 1, 4 times 74. Okay, 74 times 4, 16, 1, 296. Ah, we're not there, are we? We're short, so let's do x equals 76. 4 times 76 minus 1. 4 times 76 minus 1, Mr. Crone. Okay. 75. 4 times 75 we already knew was 300. So we start to figure out methods that make it a little bit quicker, right? All right. You can use algebraic expressions for a frame pattern to find the number of tiles you need to any size frame. The variable, which generally represents any number, changes to a specific number when you know the side length. So you can replace the variable with that number and simplify the expression. This process is called evaluating. So this part right here, that's evaluating right here, that expression. This right here is evaluating that expression. Okay, that's what that means. It can be done with any algebraic expression. For example, if you know that x equals 2 in the expression 3 times x plus 5, you can calculate the value of the expression by replacing x with the number 2, writing 3 parentheses 2 plus 5 equals 11. Gerald created some more algebraic expressions for fun. Evaluate expressions for the given value of the variable. All right, let's just do it. 2 times 3. Whoa, what happened? 3 plus 6, right? Because x equals 3. 6 plus 6 is 12. Try these on your own, so that you're kind of doing this on your own, but your answer in this case should be 3. Try on your own. Let's go down here. Try this one on your own, and you should get 8. Try this one on your own. Make sure you do what's inside the parentheses first. Try this one on your own, and you should get 8 also, I believe. Yep. Okay, try it again. Bonnie's frame shop employees, Parker and Barrow, were trying to find a total number of tiles needed for a picture frame that had 24 tiles along a side. Parker evaluated the expression 4 times x minus 4 by substituting x equals 24 into the expression, and he came up with 420 tiles. Barrow reasoned that Parker's answer was wrong. What mistake do you think Parker may have made? All right, 24. So we have 4 times 24 minus 4. And what happened? How did he get 420? Well, I think what we did, make sure I have them right. Yep. 4 times 24. 4 times 24 is 4 times 96. 96 minus 4. Whoops, 96 minus 4 is 92. Well, how did he come up with 420 then? Right? Huh, that's weird. So if I'm looking at that, what do you see that he could have done? Well, I would guess 400. Actually, I'm not 100%. Oh, no. Did he subtract first? 4 times 24 minus 4. Did he screw up and do this? 4 times 24 minus 4, which is 20? No, 80. That doesn't work, right? Actually, I'm not 100% sure why he got 420. That is a really odd number for 1. I'm not sure. It's not right, though, is it? Oh, I got it. I'm sorry. There we go. So when we did 4 times, so what's important is the way it's written right here. If x is 24, we have 4, and what happens sometimes is some students think that you just put a 24 right here, because that's what x equals. The problem is there's a hidden multiplication in there. So when he put that in there, he didn't multiply, and then he just got 420, right? But there's a multiplication in here that should be in there that it wasn't listed. There. Took me a moment. I forget that that's a common error, common mistake. These bottom 2 problems were just bonus problems in here, and you do not need to do. Okay, do not need to do. They were just more for extra stuff in class. Closure. Evaluate 4x plus 8 for x equals 5. 4 times 5 plus 8. 4 times 5 is 20. 20 plus 8 is 28. There we go. Have a great day.